In this video, I'll be working through the question you can see on the screen here from the summer 2025 Cambridge A-Level Maths paper 1-3. I'm going to try and show you how to do this question and not just the solution. So definitely pause and rewatch certain parts of the video as you need to. If you're looking for a different question from this paper or a different paper entirely, you should be able to find a playlist in the description below or have a look around my channel. Okay, let's get into the maths. In question 7, they tell us that there's a curve such that dy dx is equal to this. And then they want us to find a set of values for which y decreases as x increases. This is quite a tricky question, so it's going to take me a couple of minutes to talk about the setup to it. First of all, let me draw a curve. I actually am able to roughly draw this curve from the information they're given, but let's pretend I'm not. I just draw a generic curve like this. I have no idea what it looks like. What they are asking us, first of all, remember this isn't the curve, this is the derivative of the curve. This is dy dx. The curve is y equals, this is dy dx equals. What they're asking us about is, as the set of value of x increase, y decreases. Did I say that right? Find the set of values for x for which y is decreasing as x increases. Now x increases going left to right, so minus a million, minus half a million, 0, half a million, a million. It goes from left to right. So what does it mean y is decreasing? So to have a think of it here, as I go this way, y is increasing and decreasing. So between here and here would be the answer they're looking for. This is when y is decreasing. Also between here and here, from here to here, this is the set of values for x, the y is decreasing. And on my drawing from here all the way to where my drawing ends. This would be the answer for my drawing. The problem is my drawing was just made up. That's not what they're looking for. We need to use this information to answer this question. Hopefully the answer is clear to you at this point. But think of what the derivative tells us. The derivative tells us about the slope. The slope at this point is here, the slope here, the slope of the tangent, that is. So it tells us about the slope of this line that my marker is making as I go along this curve. And when the slope of dy dx is greater than 0, it's going up. When it's less than 0, it's going down. So really what they're asking here is find the set of values for x such that dy dx is less than 0. That's really what they've asked you here. And to write that again, that's 3x squared plus 10x minus 8 is less than 0. This is what they want you to know about. At this point, I am going to assume we can draw this. This is a quadratic equation with a positive number. That means it looks like this. There's 3 possibilities for a quadratic at the x-axis. Maybe the x-axis is down here and it doesn't touch it. That means it would never be less than 0. I don't think they're going to give us that. The other possibility is the x-axis touches it just once, in which case it would never be less than 0. It would be equal 0 once. Again, maybe they give us that, we'll find out. But the one we'll just assume. The x-axis probably looks like this. So when you have an inequality like this, think of what it's telling you. It's telling you that this quadratic is less than 0. Less than 0 is under here. So really what they want to know is, what are these two numbers? And the answer is everything between there. So forget about the inequality. Let's just find these 2 points. Forget about this, let's just solve this one. This is a bit easier. 3x squared plus 10x minus 8 equals 0. If you solve this, you'll find these 2 points. And if you find these 2 points, I know the answer to the inequality is just everything between there. So to try and solve this, it's something you can factorize, although it's not that easy. How do you get 3x squared? The only way is 3x by x. Remember, if you're not able to do factorization, or you're just not that good at it, use the minus b formula. It will work perfectly well for you. Okay, we're thinking of 2 numbers that multiply to get 8. and then when multiplied by 3 and a 1, we'll get 10x. I'll try 2 and 4. Maybe a 2 here. Let me write it in. 2 here and a 4 here. This looks like it'll work. 3 times 2 is 6. 4 times 1 is 4. 6 and 4 make 10. This looks good. The problem is I want plus 10. So this would have to be a plus and a plus. But then the problem is I want minus 8 when they multiply. So that actually doesn't work. It looks like it works, but it doesn't quite work. The one that does work, if you play around with it, you see, is 4 here and a 2 here. 3 times 4 is 12. 2 times 1 is 2. 12 and 2 also make 10. We would need a plus 12, take away 2, and that works for everyone here. So the answer here would be x is equal to 2 over 3, or x is equal to minus 4. Put that back in our picture here. Let's see, minus 4 is the smaller one. So this guy here must be minus 4, and this one here must be 2 over 3. Again, go backwards and think about the inequality. The answer to this inequality is x has to be bigger than minus 4. Bigger than minus 4, and it has to be less than 2 over 3. That's the answer to this question. That's the answer to this inequality, and this inequality is the answer to the idea of when this curve is increasing or decreasing in this case. Alright, that's it for part A. Let me clear off most of this and we'll do part B. If you are finding my videos useful and would like to help the channel out, on top of liking and subscribing, probably the best thing you could do is to tell other people doing the exam about my channel. Maybe you could share this video in a class WhatsApp group. Then if you feel I've really deserved it and you would like to buy me a coffee, you could become a member on YouTube or on Patreon. You should find links to that in the description below. Before we jump fully into part B, let me talk about the curve we're using in this question, where dy dx equals this. I actually do roughly know what this looks like, because I know that the integral of this is the curve, and the integral of quadratic is a cubic. That's it's common-ish information. A cubic looks like this, or in fact looks like this. Is it going up or down? Or sometimes there's a cubic looks like this in the middle. Now from our answer of part A, I actually know which of these this cubic will look like. I know that between 2 points, y is decreasing. Y is decreasing here, between here and infinity. Between here and infinity. This one, y is always decreasing. Oh, there was another possibility. This one, y is always increasing. So this is out, this one's out. The only one that makes sense is between here and here, it's decreasing. That would mean this point must be minus 4, and this is 2 over 3. I roughly know what this drawing looks like from the information in part A. But don't worry too much if you didn't know all of this. I'll still point out ways you could do this question. Let me clear off some of this. We'll leave this top drawing up here. Okay, again, let's assume you don't know the drawing looks like this. Going on to part B, they tell us in part B that it is given that there's a maximum point of the curve where the y coordinate is 27. Find the equation of the curve. Now, the information we found from part A was, here's the numbers here. We found minus 4 and 2 over 3. Look, if you did know to draw the picture, like I said, I would now know this point here must be minus 4, 27, because it's a maximum up here. Oh, by the way, I think the question is wrong slightly. They say it's given that the maximum point of the curve. Well, this curve goes off up to infinity. There's points much bigger than 27 on this curve. They probably should have said like local maximum. But anyway, that's not too important. So I know this point is minus 4, 27 because I knew the drawing. Let's assume I didn't. What you should know is that there's 2 points, one of them at minus 4 and one of them at 2 over 3. And maybe both of them are maximums, both of them are well, you know one of them is a maximum because they told you there's a maximum there. But you should know that there's 2 possible points, one of them's a maximum. You would want to find out which of these is is your maximum before you move on. You could just try both of them and give two different answers. You'll probably get 3 out of 4 for the question. But ideally you want to figure out which of these is a maximum. One way, like I just said, is knowing the shape of everything. That's a pretty good way a lot of the times to do it. If you didn't know that, what I would like to see would be you to find the second derivative. If you found the second derivative of this, that's just 2 times 3 is 6, 6x plus 10. This is the second derivative. If you did that at these 2 points, so the second derivative at x equals minus 4, put minus 4 in here, you would get minus 24 plus 10, so that's equal to minus 14. And once again, put the second derivative, or find the second derivative at x equals 2 over 3, and you'd find, I did it earlier, you'd find it's actually 14. This is bigger than 0, meaning that's a minimum. This is less than 0. This is the maximum. This is the maximum one you're looking for. You now know minus 4 is, this should be equals minus 4. Minus 4 is the point we know about. So that's 2 different ways you could do that. You would have had to do something like that to get the full marks here. Okay, at this point then, we know there is a curve. It doesn't matter if you don't know what it looks like. There's a curve. It has a maximum point, and that point is minus 4, 27. How do we find the full equation of the curve? Most of the information is here. The derivative is this. The curve is the integral. Y is equal to the integral of dy dx. This is a very common question to come up. We just have to integrate dy dx to get back to y. And it's an easy enough one to integrate. The integral of x squared is x cubed. We just divide by 3. So we come out front and divide by 3. There's a 3 there already. So we get 3 divided by 3. The next one, x becomes x squared. And we divide whatever's here, which is 10, by whatever's here, 2. So we get 10 divided by 2. The next one, there's no x, so we put an x in. We add a constant in, because think if you differentiated this, this would disappear. This would become minus 8. This would become 10x. This would become 3x squared. And let me clean this up here. This is x cubed plus 5x squared minus 8x plus some constant. This is most of your answer. This is the equation of this curve. This y equals. This is what they're looking for, except they would like to know what number goes here. To get that, we use a point, any point on the curve, and we know this point here. If you didn't do all this, you could have just put in this point or this point and play around. You would have got one wrong answer and one right answer, but at least you would have got a right answer, I suppose. Let's go ahead and, yeah, I think we'd squeeze it in up here. Let's go ahead and put in this point here. We know y is 27 at a certain point. We put in minus 4 here. That's minus 4 cubed plus 5 times minus 4 squared minus 8 times minus 4 plus c. Clean all that up. We get 27 is equal to, yeah, put all this in calculator, you get 48 plus c. I'll leave a c1 there. It's just an old habit I've started. 27 minus 48 is minus 21 is equal to c1. That will get you full marks. Although I think the examiner, there is a possibility, a small possibility, they won't give you full marks for that. They might want to see you write this line one more time, but instead of c1, put in minus 21. That's definitely full marks. Okay, hopefully I helped you understand or think about that question a little bit more. That's it for question 7. If you have any follow-up questions, let me know in the comments. I'll do my best to get back to you. Thanks for watching and have a great day.